I'm Soutaro. I'm from Tokyo, Japan. This is second time to me to come Taipei. So the first time was the last year's RubyConf Taiwan. So yeah, it's super nice to have a talk, a presentation here again. So I started working for the type checking about Ruby programs. It was 2004. It was 15 years ago. So there was no GitHub, no Twitter. Mark Zuckerberg released the first version of Facebook. So it's 15 years ago. So I feel it's crazy. So this time I'd like to. This is the outline of my presentation. So I will explain the overview of the type checking for Ruby 3. So I will explain how we are doing what we are doing for the Ruby 3 type checking project, and I will explain next the benefits of the type checking. And I will finish my presentation with the quick tour of my type checker or Steve. So I think that some of you see this presentation, this slide in Ruby Kaigi, and maybe that everyone see the same slide, the today's keynote. So my talk is about the third point, the third biggest feature improvements in Ruby 3, about the static analysis. So for the static analysis, we try to implement a type checking tool for Ruby 3. So it is to detect the types of each Ruby expressions without execution, without executing the Ruby program. And the goal of the type checking is to help the development. So for this project, the performance is not the goal. So because that to improve the performance by type checking, we need much more precise analysis, and it feels like that it's impossible for Ruby. But yeah, this is my impression. So, and I think that we can discuss about this with the Ruby team or maybe the Tracker Ruby team. So I think that I will catch Charles later. So what the type checking will do is to detect the type of the variable. For example, the type of the Taiwan variable will be the conference. It will be an instance of conference object. Or what is the type of the each method? It will take block, and the block will receive top object. And each method returns itself. Or what is the type of the talk.pika.email to be string? So using type checkers, we can reason the property of the program without execution. So we call ourselves the Ruby and Types project. The members include someone from the Ruby core team, including Matt, and the type checker developers working together. So it includes the geometry and the solvers team from Stripe. It includes the Professor Jeff Foster. He develops another type checker called RDL as his research project. And Yusuke Endo develops a type checker called Type Profiler, and I developed Steve. So we have meetings almost monthly and discuss how is the progress, or we need to do some collaboration and to develop some of the foundation of type checking for Ruby. So we have several sub-projects. The first one is a level 1 type checker. It's called the Type Profiler. The second group is level 2 type checkers. This group includes Solvec, RDL, and Sleep. And the third group is the type signature language. So we define the language to write the type of Ruby programs. it's called RBS, and I developed a Ruby library to manipulate the signature files. It's called the Ruby signature. So this shows the relationship between each project. Type profiler uses and sometimes generates the type signatures, and the level 2 type checkers reads the type signatures of libraries or applications using the Ruby signature or RBS. So, but currently the Solvet and RDL uses their own type signature language, and the Steve is the type checker. It uses Ruby signature as I developed both of the tools. So, what is level 1 type checker? It means that it do the type checking without any extra codes. So it means that you don't have to write inline type annotation in your Ruby program, or you don't have to write the signature of your programs. So it only reads the normal Ruby code from the file, and it tries to infer the types of each expression as much as possible. It uses the type of signatures, so the type of libraries from signatures. So the library means the standard library, or some of the gems will sit with type signatures. But you don't have to change, you don't have to modify your Ruby code, or you don't have to write type signatures. So it's a very good thing that you just run the type checker to type check the tools, but the disadvantage of the level 1 type checker is that probably many expressions in your Ruby program will be left untyped. So the level 1 type checkers cannot infer the types of a lot of Ruby programs. So it means that no bugs can be detected around the untyped expressions. So using the level 1 type checker, you will overlook a lot of problems. So generally, there is a trade-off between how much you have to do for type checking and how much you can receive the benefits of the type checking. So the level 1 type checker is to minimize the cost of type checking, and it sacrifices the precise coverage of the type checking. So level 2 type checker is the opposite. It requires writing inline type annotations or the type signatures of your program, but it detects more types of the more Ruby expressions. So I'd like to show the two of the level 2 type checkers examples. So on the left, the example is from Solvet, and on the right, the program is using Steve. So the red lines type annotations requires the Solvet or Steve requires. Solvet uses embedded DSL as type annotations. So it's an usual Ruby method called the extend is usually the extend. And the opposite, the Steve requires type signatures, and the inline type annotations are given as comments. So the last one is the Ruby signature language. This is an example of the signature of array class. So you may see that it's similar to Ruby, but it's different. So it has class or include, but it has def syntax. And instead of writing the implementation of the method, it has the types after colon. So the language defines the structure of your Ruby programs. So it means that you define the type of classes, type of modules, and maybe you write the relationship between them, like the inheritance one is in. And interface is another concept it is introduced in the RBS. it means abstract types. It doesn't appear in the Ruby class, but it's used for type checking. So we define methods and instance variables, and the types includes the generics or unions or tuples or optionals. So the type language is rich enough, and I believe that we can write the types for the most of the Ruby programs. So I want to note that the syntax is work in progress. So if you find some questions or some difficulties on writing the types of your Ruby code using the language, let me know, and then I will update the language. This is one correction of the Maths keynote. So the URL is old. So the repository is moved to Ruby organization. So yes. Okay. So this is a quick overview of each group of the projects. So at the beginning of the Ruby and Types project, we tried to provide some of the level 2 type checkers for Ruby 3, but currently we changed the plan a bit. So the level 1 type checker and type signature language will be part of Ruby 3, but the level 2 type checkers will be another optional tools. So then the next program is that you might have a question that how much you should adopt to the type checking. So this is a spectrum of how much you do for type checking. On the left, there is no type checking. So on the right, it's free type checking your program. You write the line annotations and you write some signatures. And between the two, we have several options. You can type check your program. It uses the library signatures, but you don't write any inline annotations or signature of your program. Or you may generate the type signatures of your gem, and you can ship the auto-generated type signature with your gem to help your library users to type check their program. Or maybe you write signatures by your hand, but you don't want to write the inline type annotations in your Ruby code. The first one is no type checking, so I think I don't have to explain something about this. So this is the second option, type check with your library, type check your program with library signatures. So it means that you don't write the signatures of your Ruby program at all. You don't write the inline type annotations, or you don't write the signature of your Ruby program. It uses the library signatures and imports the type of your Ruby code. It might find some problems, and we have the level 1 type checker is for this approach. And maybe the level 2 type checkers can also detect some of the trivial problems. So in this example, it's almost same that in the previous example, but it's missing the speaker code. So instead of talk.email, we have to write the talk.speaker.email. I guess that some of the type checkers can detect this kind of bug. The second one is you can generate the type signature of your libraries. So you don't write the signatures of your Ruby program yourself, but you can let the type profiler to generate the type signature of your Ruby program. So this is an example I brought from the tests in the type profiler implementation. So the fib plus, the fib method takes an integer and calculates the Fibonacci of the number, then it returns the integer. So this example shows that type profiler can infer the type of this program. Another option is you write the signature of your gems, but you don't write any type annotations in your Ruby code. So you can write the type signature of your program and you ship the signature within the gem. So in this option, you run the type profiler with your test, and it will detect some mismatches between your signature and test. So this is an example. The signature of fib method is integer to integer. So you write the signature, but you also write some tests like this. So in this case, we can find the fib methods accepts the string and it should be working. So running a type profiler with the signature and the test, the tool will find that there is a missing method types. It should receive a string and return string. So using the tool, you will find you have to fix the signature, and you fix the signature, then you ship your gem with the type signatures. And the last one is to type check your code. So you have to prepare the signature of your Ruby program, and you write some inline type annotations in your Ruby code. And you can write the signature of your Ruby program manually, or you can use the type profiler to automatically generate the signature of your program, and then you can fix the generated type profiler to more precise type definition. So I think that there are at least 5 options that how much you can do for type checking. And yeah, my recommendation is the last one. So write types annotations or type signatures and that get the most out of the type checking. So this is our plans to provide the type checking for Ruby 3, and the rest of my talk assumes the level 2 type checkers. So I want to explain the benefits of the type checking, so more the detail of the benefits of type checking. So as I explained in this talk, so the goal of Ruby 3 type checking is to improve the development experience. So the type checking will uncover some of the bugs without running the tests. So it can also be an documentation with validations. So using the type signatures, you will have a documentation that what of the methods are required in the module. So it will tell you that easily understands the implementation. The type checking also improve the code navigations. So like the jump to definition or what is the type of this variable. So yeah, it will help the development experience improvements. Another benefit is the quality of your application code. It might uncover some of the bugs you've missed in tests, or it will help the development of advanced analysis. So anyway, I want to focus on the green one, the uncover bugs without running tests. So what kind of bugs? So this is the example of bugs that can be detected with type checkers. So this happens if you call update bug method with new. So I think that you should see a lot of these errors in your development. So how this error happens from the Ruby code? This is a small example. So, I'm sorry, so I assume that we are using active record in this example. So we use find by method to fetch a record from the database. And as you know, the method returns new if there is no record matching the query. So the type of the find by method will be like this. So it receives a string as a name, and it will try to fetch some records from database. And if there is no record in the database for the query, returns new. So it means that the type of the conference variable will be conference or new. So there is a chance to be a new, and it is the reason we see the errors on the update ban method code. So we want to avoid this kind of errors, and we can do several ways to fix the program. The first one is we can test if the value is new before using the value. So we add the if, and we test that the conference value is new or not. Then we can call it update ban. Or another option is that you can use the find by ban method instead of find by. So the method raises an exception if there is no record. So if there is no record, the program execution will be aborted and the conference variable cannot be new now. So this is very small example, and you will understand that what is wrong, and you can find easily how to fix the problem. But how about this? So the conference variable will be passed to another method, and we don't know if the implementation of the method has assumption that value cannot be new or not. So we have to jump to the definition of the method and read the implementation carefully, and we will find that if the method accepts new or not. So the difference can be described as a types. So if the method doesn't accept conference, doesn't accept new, the type of the method will be conference to void. Or if the method implementation allows the parameter can be new, then the type will be conference or new to void. So without types, it's really difficult to know which assumption is correct, and you have to write the implementation of method carefully. So this is the problem of the working with nils. So as I explained, the only way to avoid the new method called error is by testing if it is new or not, just before the method call. But it's easy that you can forget testing the method, testing if it is new or not. Or maybe your teammate can change some of the implementation, and one change happens on this side and another one changes in different program. So then it will be merged and the assumption is replaced. So instead of reviewing the changes so carefully, the type checkers will tell you that if you forget the test. And another important thing is that we can generalize the safety from the type checking to any union types. So this is the type of JSON values. It can be new or numeric or string or true class or false class or array of JSON or hash from string to JSON. So there are a lot of there is 7 cases and type of and value of JSON can be, and you have to carefully construct the type analysis. So that type checking should be the best fit for case or new case in constructing Ruby. So, okay, 15 minutes left. Okay, then I'd like to explain my type checker. So, it is steep. So you can install using the RubyConf commands to install steep, or you can find the source code at the GitHub repository. So I'd like to introduce the key ideas of steep, that it assumes the structural subtyping and it allows you some kind of the duck typing. And it doesn't change runtime behavior at all. So this is an example to explain how steep works. So this is an example of the conference class. It defines 2 attributes, it defines the initialize method, and it defines the speaker method, and it will return an array of speakers. And we can use the conference class like this. So we can do the conference.new method with string to make an instance of the string. Then we can push the talk object to that talk's attribute. This is the signature of the conference class. So we write the attributes, the name and talks, and the type of the attributes. And we define the initialize method. It takes a name keyword and string, and it returns anything. And we also define the speakers method. It returns array of speakers. So the steep can check if the class is used in a consistent manner with the signatures. In this case, the Ruby program has some problem that it passes a string instead of the keyword string. So the steep will detect the type mismatch error that says that it expects a name keyword, but the string object is passed. And it also checks the consistency between implementation and the signatures. In this case, the speakers, the implementation of speakers method is broken. It returns, it uses each method, so it will return the talks object itself. So it will be array of talk, so but it should be array of speakers. So the steep will detect this type of mismatch and report you to help to fix the problem. Okay, and it supports kind of the duck typing. I think that duck typing is one of the most important property of Ruby programming. It accepts any object of the classes, and it only depends on which method is defined in the class. So, for example, we can see that we define dump to interface in signatures. So it requires the left arrow operators, and the operator should take an argument of string. And we don't use the return value of the method, so it will have the type of any. And we can add the type of methods of the conference class. So we define a dump titles method. So it accepts something to the titles will be printed as a dump to type, and the implementation will be like this. So when we pass a string to the dump titles method, as you know, the string has the left arrow operator. It to append the given string to the end of the string. So it's okay. So how about passing array? It's okay. So we have push operation. And there is the common ancestors of the string and array class. It is object, and it doesn't have the left arrow operator. So this is what we call duck typing. And in fact, it does more than duck typing. So if we pass an integer to the dump titles method, it will be an error because the integer has a method of the left arrow, but it is to implement the bitwise left shift. So it requires an integer to be passed. So if we pass an integer to the dump titles method, it will raise an error. So and the Steve can detect this error. And another one is there is no runtime invasion. So the inline type annotation of Steve are comments. So there is no, how to say, the embedded DSL call, method calls. So you don't have to add a Steve to the runtime dependency of your chunks. I believe that this is better for libraries. So when you are developing an application, it's okay to have another extra dependencies. But when you are developing library, so your library users may not want to install Steve. So and I think that generally keeping the number of runtime dependencies as small as possible is better thing for libraries. So I think that Steve is better, especially for libraries. Okay, so this is the last slide. So I explained the plan for Ruby 3 type checking. I explained what we are doing, how we are doing that, and I explained several options, how you can adapt to type checking. And I explained some of the benefits of level 2 type checking. It will detect some of the bugs in Ruby programs, and it will help to handle the nils safely. And I think that it's the ability to type checking the nils. It is a best fit for the case or case in syntax. And I introduced my type checker implementation called Steve, and I believe that Steve is the best option for Ruby type checking. So yeah, this is my personal opinion, but I think so. So that's it. Thank you.
Do we have any questions from the audience? Any questions?
So you mentioned that you and the developer of Sorbet, Dimitri, and the other guy, I don't know their names. You said you meet every month to discuss your progress, is that right?
Yes, and we use the online video conference and then to discuss. It's almost monthly.
So I'm just sort of curious, as someone who's developing a library, like, partly because it seems like their library competes with yours, how much do you get out of, first, how did you start setting up these meetings? What sort of information do you share, and what do you get out of it? And how do you handle, like, when you have different choices from them? Like, have you made any changes to your design of Steve based on what you've talked about in these meetings?
Good question. Okay. In fact, I remember that some of the changes I proposed to to have, I wanted to have in the RBS was rejected by Soviet team. So I tried to implement some the structure. The object literal types. It's an unnamed type, and it defines the required methods, and then it will help to writing the smaller interfaces. So I proposed to implementing in the RBS, but it's rejected. So yeah, they say that the improvement is not so essential to the. It doesn't improve the expressiveness of the type systems essentially, but they need to implement more. So it's not only for speed, but the changes to RBS requires a lot of efforts on the type profilers or maybe RBS. So yeah, something that happens.
Thank you.
I got a question. Hey, it's really interesting to see what you're doing. What is the biggest program you've tried it on?
Program we had said. Okay, so one of the biggest problem to TypeScript Ruby program is that it's essentially untyped. The design of the classes are untyped. So for example, we have method in object. So it returns it receives a symbol, it is a name of method, and then it returns a method class instance. It's a super useful method, but some of the classes uses method for other purpose, for other meaning. Like the HTTP client library uses the method to the get or post or put or that kind of thing. So there is a mismatch between the two implementation of the class of the same method, and they are incompatible. So so that how to say the usual type system doesn't allow this kind of thing. So it's a source of headache so for years. But yeah, I think that I recently found a solution. So yeah.
Great.
Sorry, do you mind? I might have misheard Samuel, but I thought he asked, what's the biggest application you've tried this on? Is that right? Is that what you meant?
Yes.
Like not big problem, program. Yeah.
Oh, I'm sorry, the application of...
Like what's the biggest Ruby program?
I have tried Steve.
Yes.
Okay.
Yes, exactly.
Oh, I'm sorry.
That's okay.
Yeah. So I have tried using Steve in some library. It's in January we are using inside in my company. So it's about the library itself is about the 2,000 of the lines of code. It's not big library, and then we have about the 20 of the Ruby program. It depends on the library, and we type check the library itself and see the applications. So does it make sense? Yeah.
Hey, great. Big round of applause for Mr.